Hello and welcome to my YouTube channel, amazing people, students and lovers of chemistry out there. It's been an absolute pleasure connecting with you on this space where we take the concepts of science from complex down to simple. And on today's episode in this series where we've been learning how to balance chemical equations, we're going to be learning the concept of the algebraic method. So without any further ado, let's get into what we have for today's video. So the algebraic method is a method for balancing chemical equations that come into play when you have big molecules or messy compounds. So in cases like that, using the trial and error balancing method can get you confused. Okay, so when you have either an equation that has big molecules, and by big molecules I mean a molecule that contains plenty elements and then many atoms. So when you have a situation like that, you really want to use the algebraic method. It's like using math tools to solve a chemistry puzzle. So we're going to be going into details step by step about what the algebraic method entails. We'll solve a couple of questions and then draw the curtains on today's video. So let's get into the first step. We're seeing the reasons why and when you must use the algebraic method. So first things first, the algebraic method can be used to balance any chemical equation, no matter how simple or complex that equation is. But then there are certain conditions that you want to have in place before you can use the algebraic method. So condition number one is that you want a systematic way to balance any equation. Condition number two is that the trial and error method gets too messy or too slow. And then condition number three is that you're dealing with multiple unknown coefficients or larger molecules. So that being said, let's take care of a couple of questions and then we'll draw the curtains on today's video. Example number one, we have the example of the combustion of ethane. Ethane over here is being combined with oxygen to form carbon dioxide and water. And we've been asked to balance this chemical equation. So first things first, when you want to balance a chemical equation using the algebraic method, the first thing to do is to assign letters to represent the coefficients for each compound. So here is what we mean. For instance, let's say you have this equation, hydrogen combining with oxygen to form water, which is H₂O. This equation at this point is not balanced. So if I were to balance it, I'll just simply put a coefficient of 2 in front of hydrogen and a coefficient of 2 in front of water on the right hand side of the equation. Now watch this carefully. You can see there is a coefficient of 2 standing in front of hydrogen. There is a coefficient of 1 standing in front of oxygen, even though it is not identified. And there is a coefficient of 2 standing in front of water. What this simply means is that at the point where this equation was not yet balanced, hydrogen plus oxygen giving us water, if we were to use the algebraic method, we'll simply use letters A, B, and C to represent these coefficients, number 2, B representing number 1, and C representing number 2. So that is the first step to solving or to balancing a chemical equation using the algebraic method. We'll simply use letters to represent the coefficients that should be assigned to every compound. So let's do that very quickly. We have ethane, C₂H₆. So let's assign a coefficient A. We can assign any letter, okay? But for the sake of being simple, we're assigning the letters A, B, C, and D. So we have letter A in front of ethane plus the letter B in front of oxygen O2. And then we have the letter C in front of carbon dioxide CO2, and then plus the letter D in front of H₂O. I'm sure you saw how all these letters were assigned. Alright, so that's the first step to solving and balancing a chemical equation using the algebraic method. Now the second thing we want to do is to assign equations using these coefficients to each element present in the chemical reaction. Now here is what we mean. We have carbon, we have hydrogen, we have oxygen, and Okay, that's all the elements that we have in this chemical reaction: carbon, hydrogen, and oxygen. So what we are to do is to form equations for each element. So let's do that very quickly. I'm showing you everything step by step. So for carbon, the first thing to do is to identify the positions where we have carbon on the left hand side, which is the reactant side. On the left hand side, you can see over here that we have a carbon atom, and that carbon atom has a subscript of 2, and the letter that is representing the coefficient is the letter A. So that simply tells us that on the left hand side, carbon has a number of atoms that are represented by 2, which is the subscript, multiplied by A, which is the coefficient. This is the coefficient A, and this is the subscript 2. So the number of atoms will simply be the coefficient A multiplied by the subscript 2. So for carbon, on the left hand side, the number of atoms that we have is represented by 2A. Did you get that? I'm sure you did. Now on the right hand side, you can see we have carbon over here as well. Now carbon has no subscript, or the subscript of carbon in this case is number 1. Alright, and then the coefficient attached to the compound that contains carbon is the letter C. So therefore the number of atoms for carbon will now be C multiplied by 1. That gives us C. And according to the law of conservation of matter, of mass, if we're to balance a chemical equation, the number of atoms on the left hand side must be equal to the number of atoms on the right hand side. So that means what we have on the left for carbon, which is 2A, must be equal to what we have on the right, which is C. So for carbon, the first equation now becomes 2A is equal to C. I'm sure you're following every step of what we are doing. So now we've done for carbon. Let's move on to the next element, which is hydrogen. Now hydrogen on the left hand side of the chemical equation has a subscript of 6 as identified over here. Alright, and then it has a coefficient of the letter A, because this A affects everything that is in this compound. So now that we have hydrogen, it has a subscript of 6 multiplied by the coefficient of A. So on the left hand side, it means that the number of hydrogen atoms that we have will be 6 multiplied by A, which is 6A. On the right hand side, you can see we have hydrogen over here. It has a subscript of 2, and then it has a coefficient of the letter D. So on the right hand side, it means that the number of atoms of hydrogen that we have will be D multiplied by 2, and D multiplied by 2 will give us 2D. So according to the law of conservation of mass, the left hand side 6A has to be equal to the right hand side 2D. That is the second equation. I'm sure you're following every step of what we're doing. Alright, now we've done for hydrogen, we've done for carbon. Let's move over to oxygen. Oxygen, which is the third and last element we have in this chemical reaction, has an atom over here. On the left hand side, it has a subscript of 2 and a coefficient of the letter B. So for the left hand side, the number of atoms of oxygen we have will now be B multiplied by number 2. So we have 2 multiplied by B, which is 2B. On the right hand side now, how many atoms of oxygen do we have? We have an atom of oxygen over here, and it has a subscript of 2, and the coefficient is the letter C. So therefore it becomes 2 multiplied by C, which is equal to 2C. And don't forget, there is also an element of oxygen over here. It has no subscript, or the subscript is 1, and then the coefficient is the letter D. So we have D multiplied by 1, which is equal to D. So the total number of oxygen atoms on the right hand side now becomes 2C plus the letter D. So for oxygen now, the left hand side is letter 2B, or the left hand side is 2B, and it has to be equal to the right hand side, which is 2C plus D. This is the last equation. All right, now, so at this point, we have the three equations that we have formed. The next thing to do for balancing chemical equations using the algebraic method is to assign a small whole number to any of the letters. It can be the letter A, can be the letter B, can be the letter C, can even be the letter D, whichever one we want to assign a number to. So we can assign a number to letter A, B, C, or D. So let's assign, for instance, or let's assume that A is equal to number 2. So if we do that, this equation over here now becomes 2A is equal to C. So now we have assumed that A is number 2. So anywhere we see A, instead of putting A, we put 2. So the equation now becomes 2 times 2 equal to C. So therefore, C is equal to 4. So now we have A to be equal to 2, C is equal to 4. So we can go ahead now to calculate the other variables. This equation, the second one, now becomes 6A is equal to 2D. Since we know the value of A, it therefore becomes 6 multiplied by 2 is equal to 2D. 6 multiplied by 2 gives us 12. 12 is equal to 2D. D will now be equal to 12 divided by 2. D is equal to 6. So we have A to be 2, C to be 4, D is equal to 6. Let's go ahead and find the last one, which is the letter B. So we have 2B is equal to 2C plus D. We know the value of C and we know the value of D. So let's find what B is. So 2B will now be equal to 2 multiplied by C. C is 4 plus D, which is 6. So we have 2B is equal to 2 multiplied by 4 gives us 8 plus 6. So therefore 8 plus 6 is equal to 14. So therefore 2B is equal to 14, and then B will now be equal to 14 divided by 2, which is 7. So we have all our variables now. A is equal to 2, B is equal to 7, C is equal to 4, and then D is equal to 6. So do you know what this means? We can go ahead and put it into the equation now. Let's do that very quickly. Now this is what the equation looks like. And remember, we assigned variables. We said A in front of C₂H₆, B in front of O2, C in front of CO2, and then D in front of H2O. So now we can now substitute the values or the letters for their real numbers. So A now is 2, so we'll write 2 in front of C₂H₆, plus B is 7, so we'll write 7O2, giving us C is 4, we have 4CO2, plus D, which is 6, we have 6H2O. This is our final balanced equation. Now we can do a final check to see if the number of atoms of each element on both sides are balanced. So let's do that very quickly. The first element that we have is carbon. Okay, so carbon on the left hand side, you can see over here, it has a subscript of 2, and then it has a coefficient of 2 over here. 2 multiplied by 2 gives us 4 on the left hand side. On the right hand side, you can see carbon over here having the coefficient of 4. So 4 on both sides means carbon is balanced. The next element on our list is hydrogen. Hydrogen has a subscript of 6 over here, and you can see it has a coefficient of 2. 2 multiplied by 6 gives us 12 on the left hand side. On the right hand side, hydrogen is over here having a subscript of 2 and a coefficient of 6. 6 multiplied by 2 gives us 12 as well. So you can see that hydrogen is also balanced. The final element we have is oxygen. Oxygen is over here having a subscript of 2 and then a coefficient of 7. 2 multiplied by 7 gives us 14 atoms of oxygen. On the right hand side, oxygen is over here having a subscript of 2 and then having a coefficient of 4. 4 multiplied by 2 gives us 8, and then oxygen is over here as well having a subscript of 1, even though it is not identified, and a coefficient of 6. 6 times 1 gives us 6. So 8 plus 6 gives us 14 atoms of oxygen present on the right hand side. So we have 14 atoms of oxygen apiece, both on the left and on the right hand side. So our equation is fully balanced using the algebraic method. I'm sure you saw all the steps that we took. So our final balanced equation, let me write one more time. 2C₂H₆ plus 7O₂, yielding 4CO₂ plus 6H₂O. I'm sure you enjoyed every bit of what we did in this lesson. If you did, please like, share, and subscribe, because we're going to be moving on to another question in the next video that I'll be uploading. And here is a sneak peek into what we'll be doing. We're going to be dealing with this question using the algebraic formula. So I'd like you to stay tuned for then. Up until then, my name is David, the billionaire teacher, and all I do here is to take the mystery out of chemistry so you can make history. I will see you in the next video.